also in particular today is all about how we here in the, what we call the headwaters, where all the waters that flow to the seacoast start, and how we're connected down to where the freshwater meets the saltwater. And that's a lot what Alyson's going to talk about today. And to that end, I have on the back here, if you're interested when you leave, copies of the most recent State of Our Estuaries report by the Piscataqua Region Estuaries Partnership, and also the Citizens Guide that they produce to ways that we can act in water-friendly ways and things we can do to improve water quality around us. So I encourage you all to take those on your way out. Just a little bit about AWA, if any of you don't know. We serve the communities of Wakefield and Acton. Our service area is all the water bodies in Wakefield, and then the ones on the border in Acton, because there's also the Acton-Shapley Youth Conservation Corps that takes care of the Mousom watershed. And we work with landowners to help keep their properties from sending polluted runoff into the lakes with our Youth Conservation Corps, which is a paid group of young people who install erosion control practices. Mainly they haul rocks up and down hills all summer long, which is awesome. And then we partner with the states, the towns, the lake associations, the road associations, and all the other community groups to address the other pollution issues, whether it's roads or development, whatever issues come up. We offer our Wonders of Water program, where we're in the Acton Elementary School and the Paul School, working mostly with middle school. Where Amy's been working with the 4th grade in Wakefield and the 7th grade in Acton raising brook trout, which they're going to release in a couple weeks in local rivers, which is exciting. And then the 6th grades, we're gearing up to take them out to do stream macroinvertebrate studies, which is basically looking at the water bugs in the streams at the Province Lake Golf Course, which we do at the end of May. Coming up in July, we're going to have our first annual water fair in Turntable Park in Sanbornville, which is going to be an event geared towards families just to do some water-related fun activities, some learning and some just plain fun. So keep your eye out for information on that. It's July 28th, Turntable Park in Sanbornville. And then the only other thing I want to mention is we're always looking for volunteers, whether it's with our school programs or helping with various events that we do, lots of different things. So if you're ever interested in learning more about volunteering with AWA, just give us a call. Just a little housekeeping. If you have your cell phone on you, please put it on mute, which I'm going to make sure I'm going to do right now because I might not have myself. Bathrooms are right out this door on your right. Exit is there and there. I think that's it for housekeeping. There are cookies and drinks on the way in the back, so help yourself after the talk. So I want to introduce you to Alyson Eberhardt, who is the Coastal Ecosystem Specialist for UNH Cooperative Extension in New Hampshire Sea Grant, where she works with communities, schools, and scientists to research, monitor, and restore coastal habitats. She coordinates a citizen science program called the Coastal Research Volunteers that trains citizens to work with researchers on local coastal research projects. In addition, she's pursuing a PhD studying salt marsh habitat connectivity and use by the American eel, Anguilla rostrata. Is that right?
Yeah.
And I just have to say, I've had the opportunity to work with Alyson on several different projects, and if you ever want to have more fun than you've ever had in your life outside, get involved with Alyson's programs because they're awesome. So, thank you, Alyson.
Well, hi everybody. Thank you so much for coming out this afternoon, especially to hear about American eels. You are my kind of people. And so what I'd like to do today, really my primary goal here, because when you read this title, The American Eel, Our Most Fascinating Fish, you're probably thinking, oh, that's bold. You probably all have some fish that you may think is fascinating, and it may not be the American eel. So my goal is if you have walked in here not thinking it's the most fascinating fish, then hopefully you'll walk out at least time for questions. So that's the plan. Okay, so first their life history. This is really, I'm going to point. I'm tall enough, right? This right here is really the range of American eels. They're all the way up in Greenland and Iceland, all along in the Atlantic seaboard. You can see they head all the way up the Mississippi and then down to the northern coast of South America. So their range is quite extensive. And when he found the smallest eels, he said that's where they're coming from, and that was the Sargasso Sea. So the eels he was finding were this life stage. This is the larval stage. It's called the leptocephalus. Plural is leptocephali. And at this life stage, they don't actively swim. So what happens is they hatch, presumably, their eggs, right, their fish. They hatch into this larval form. We haven't seen it, but we guess that's what's happening. They catch the prevailing currents that are coming down here. The Florida current comes down into the Gulf of Maine. The Gulf Stream comes up here, and they just get distributed randomly. So the currents are just, they're not like a salmon that has a homing instinct. They just are randomly distributed throughout their range. Then as they start to get closer to the coastline, they transform into this. And I apologize, I know these are a little blurry. They didn't look so blurry on my computer screen. They transform into this, and this is the glass eel. So when they're glass eels, that was that picture on the title screen. They're about this big. They're see-through. That's the telltale sign of a glass eel. And these are very valuable right now. So they spend a little bit of time, a few months in the glass eel life stage. Then they don't get much bigger, but they start to get their pigment. They start to turn brown, and those are the, I don't have an Elver. Sorry, backtrack. They start to get their pigment, so now imagine this, but it's brown. That's an Elver. Then they metamorphose into this life stage. This is the yellow eel. They spend most of their time in this life stage. If you've ever caught an eel in the lake or in the river, you've most likely caught this life stage. And so the males tend to spend about 6 or 7 years in this life stage. Females spend more, maybe 15, 20, up to 40. Yeah, do you have a question?
Freshwater, that.
Fresh or salt, and you'll learn more about that later. Stay tuned. Then, so this is the sub-adult. This is kind of the teenager life stage. And then when they become sexually mature and they're ready to reproduce, they metamorphose into the silver eel. And now you can see their eyes look a little different. Their eyes get really big because presumably they're going to swim at at depths where it's very dark, so their eyes enlarge. The other thing they do is they seal off their guts, so they stop feeding. When they're ready to make that journey back to the Sargasso Sea, they stop feeding. And so they've spent that 6 to 20 plus years really bulking up and building up their fat reserves, as well as reaching sexual maturity, so then they're ready to outmigrate. So then they make their way back out to the Sargasso Sea, where there's a big spawning event. The females release their eggs, the males release their seed. It's all one big conglomeration, so we think, and then they die. So they are panmictic, which means they are randomly breeding, and they are semiparous, which means they die after breeding.
Is it in the thousands? Or?
Like millions or billions, we think. Again, yes, and everything I say is with we think, because again, we know very little about what's happening there. What I can tell you is there's an analog process happening over in Europe, and they reproduce in the same place, but they are segregated by time. So American eels have a little bit shorter of a drive to get to Sargasso Sea, so they get there first, and they do their breeding first. And they tend to stay to the western part of the Sargasso Sea. It takes a little longer for the European eel to come down, so then they get there a little bit later, and then they stay more to the eastern part of the Sargasso Sea. But we think there is some inbreeding, or hybridization, I should say, between the two. And so here's just a little bit bigger picture of what's happening with the currents. You can see the Gulf Stream's coming here. Here's the Sargasso Sea. Notice it's a giant question mark. This is where we think they're spawning generally, and then they just drift. They just drift and drift and drift until they make it inshore. Okay, now there is generally consensus among the scientific community that eel populations are in decline. The challenge, like many species, but certainly many highly migratory species that exploit many resources and many different types of habitats, there are a lot of drivers. And we can't say, oh, eels are in decline because of this, So we fix this, and now we're good. There's a lot of factors here, so I'm just going to step you through those. The first being overfishing. Glass eels / Elvers, there's only a fishery in 2 states. One is right here in Maine, and then there's a much smaller one in South Carolina. There is a commercial fishery for the next life stage, the yellow eel, in many states along the eastern seaboard, most states along the eastern seaboard. And then the silver eel, I know there's a remnant fishery here in Maine. I don't know about other states, but only the people that are grandfathered in have permits, and I think as soon as they lose them, those permits go away. Do you have a question?
What do eels eat?
Ooh, I like that question. So eels eat whatever they can get their mouths on, whatever they can find. Not people, so don't worry about your toes if you're walking around in a lake. But they'll eat fish, they'll eat clams, they'll eat shrimp, they'll eat insects. They'll eat whatever they can. They're not very picky. Whatever's around and whatever they can get their mouths on, they'll eat. The next one, migration barriers. And I should say, particularly knowing that there's a fishery here and fisheries in other states for other life stages, overfishing, pointing to overfishing as a cause is rather contentious. So I'll say that's just one of many factors being considered. The other is migration barriers. Dams, if you were to look at the number of dams in New Hampshire and Maine, you would be astounded. They are all over the landscape, so we have not made it easy for these critters to, and I didn't even say this about the yellow life stage, and you mentioned it, my apologies. Typically, the eels, once they reach the eastern seaboard, or once they reach the coast, I should say, they do so as the glass eel, then they metamorphose into an elver, and then they make their way, typically, not always, up into freshwater, and then may stay there for a long period of time. So the common name of the American eel is the freshwater eel, and that's because historically we thought that they were all trying to get to freshwater. We're going to talk a little bit more about that in a second. But so imagining that these fish, or at least some fraction of them, are trying to get up into freshwater, you can imagine, I lost you, the barrier that dams impose. Now I will say at that elver life stage, they're small enough that their weight to surface area ratio is such that they can swim up a vertical surface. So if it's wet, and this is the McCallum Dam on the Lamprey River in Newmarket, and there's a piece over here on the side where it's a much lower flow than you're seeing, and I would say if you go there in a few weeks, you will see small eels making their way up this vertical surface that's like, I don't know what that is.
Eel Lab or something?
Not there, no. They do catch them. New Hampshire Fish and Game, that's one of their monitoring locations, so they do have a little setup where they set them and they land in a bucket and then they move them over, so that kind of functions as one, but there is a fish ladder there, but the flows are too high for these little guys to get up it. So another thing that may be affecting eels, so again, the elvers can get up, but I mean there are data that show that when you remove dams, you get a lot more eels upstream. So, I mean, it makes sense. Dioxin-like contaminants, these are PCB-like substances that they've found in eels that affect their reproductive success. They affect the viability of a female's eggs. Anguilla crassus is a swim bladder parasite, so it's this little nematode worm, and I'm pointing to it. I don't know if you can see it. I hide my grandmother's picture in every presentation I give, so I just gave it away. I do think there's one more in this presentation, so keep your eyes peeled. These are nematode worms, these little itty-bitty worms that infect their swim bladders, and that affects their ability to regulate where they are in the water column, their ability to orient, and then also affects their fitness. So it starts to kind of decrease their ability of their body to function from the inside. And those were introduced through Texas, through an aquaculture farm in Texas within the last decade or two. Since I've been working on eels, we used to not find them, and then I found them inside the majority of eels that I was catching. And then, of course, habitat loss. And I'm going to talk a little bit more about this one as it pertains to coastal systems. And so I mentioned before that the common name of the American eel is the freshwater eel. And so typically, when we thought of eels, we thought of them as obligate catadromous. Obligate meaning that they have to, they're obligated to, they must do this to complete their life cycle. Catadromy means from saltwater to freshwater. So the conventional thinking was these fish had to go from saltwater to freshwater to complete their life cycle, or else they couldn't do it. They couldn't reproduce, they couldn't have babies, like this was critical to their functioning. Well, we don't think so anymore. So the current thinking is that there are a couple of ways, and of course this is nature, and nature is highly variable, and we're always trying to put boundaries and generalizations on it. So there's wiggle room within these three strategies, but generally the thinking is there are eels that enter into saltwater systems and are making their way up to freshwater, and then they stay in freshwater for some period of time, and then they out-migrate back out to the Sargasso Sea. Okay, so that was that original freshwater eel hypothesis. The second is those that stay in the estuary. So eels come in and they hang out in the estuary, and that's where they stay until they're reproductively fit, and then they leave. And so that's new. That's new. That's within the last 10 or 15 years we've been finding eels that stay there. And then last is eels that move back and forth between these two habitats, and that can happen over the course of years, that can happen over the course of seasons, or that can happen on a shorter time period than seasons, even within a month or weeks or whatever. So 3 strategies: stay in freshwater, stay in saltwater, move back and forth in between. So these are kind of new ideas, and I'm entering into my research, and I should say, as backstory for my master's research at UNH, I was looking at fish in salt marshes, and I was looking at marshes we had kind of messed up and marshes that were in better shape, and in all these marshes I was catching eels, and I would look into the literature on what eels were doing in salt marshes, and I found nothing. No one was talking about eels in salt marshes in New England. So then as I'm looking, I go back to graduate school, and I'm trying to figure out what my research is going to be about, and I'm contemplating all these ideas, and I'm talking to my lab group, and I pitch all these ideas that I'm thinking about, and I'm like, well, and then there's this one nagging thing, is that all those fish that I caught in the salt marsh doing my master's research, I caught all those eels. Like, what are they doing? They're probably playing some big role we're not even thinking about, but I really don't want to be the eel lady. And they were like, oh, but that's such a cool idea. So fast forward, here I am talking about eels, the eel lady. So what I want to talk to you about now is the research that I conducted on eels in salt marshes to figure out what they're doing there. But first, let me give you a little bit more backstory. This is Hampton, New Hampshire. Have any of you ever been to Hampton, New Hampshire? So you know it is this interesting juxtaposition of lovely, beautiful, highly functioning ecosystems such as salt marshes, juxtaposed with a ton of human development, right? So it's a challenging system. And what I want to point you to right here is this lovely salt marsh with all these meandering creeks. This is how creeks go when left unaffected. And then you see this big, weird ponding thing, and then a ton of houses, and you can kind of see a road, and then this really strange thing, this water body. And what's happening here is a tidal restriction. And basically what happened is, a road was laid down here probably 100 years ago originally, if not earlier, and to get the water to drain through, they stuck a pipe underneath, or a culvert, and they weren't worried about supporting the ecological function of the salt marsh. They were just trying to drain water. And what happened is it kind of messed up the salt marsh above that system. It created this scour pool here from water shooting through that pipe, and it reduced the tide up here. So the water that used to get up here is much smaller in amount and frequency than it used to be. So we call this a tidally restricted system, and so this is relevant. And so here's one such structure. Too small for the system. So we know that there are a lot of problems with these hydrologic restrictions where we're not getting enough water into the salt marsh. It changes the hydrology, the amount and timing of the water, it changes the vegetation, it changes the little critters that are living in the salt marsh, so it changes the food base, presumably. And so what I wanted to know was, Our hydrologic restrictions are these tidal restrictions in salt. First, how are our eels using salt marshes, and how are these hydrologic restrictions potentially affecting their use of salt marshes? So here's my rationale, which hopefully I've just stepped through with you. Eels were historically abundant. We know they're in decline. We know that new information suggests that they rely on estuaries. So what's going on? And so this just outlines what I just said. How are eels using marshes, and how does it compare between these really messed up salt marshes and the marshes that we've messed up only a little? Because I would hesitate to say there's no marshes that we've messed up at all. So I conducted 5 experiments. I'm not going to talk about all 5 of them today, but I'm happy to talk more. I could talk eels all day long. I used a technique called stable isotope analysis, which I'm going to tell you a little bit about, and that's in number 3. So the first 2 experiments were to set up, they were lab experiments to set up the field work in number 3. And then I did, well, I'll talk about the other ones later. So basically what I did is I used this technique called stable isotope analysis to figure out where eels are in the salt marsh food web. What are they doing in the marsh? What are they feeding on? Because prior to me finding all these eels in my research, in my nets, the biggest fish that we thought was regularly in salt marshes was about this big. And it's called the mummy chug. And whenever we would talk about the salt marsh food web in New England, the mummy chug was at the very top. And I'm like, you're telling me that an eel that's this big, that is potentially a predator, is not going to be playing some role in this food web? That's what I wanted to figure out. So that's what this research looked at. So bear with me as I try. Explaining stable isotope is still a work in progress for me, so feel free to ask questions. But here's the basics of it. So an isotope is when an element has different number of neutrons, right? So we're looking at a ratio of the 2. That's not relevant. The idea is it gives us a signature. And it gives us a signature depending on the type of plant. So in a salt marsh, there are, I lost this again. Oh, my finger was in front of it. C3 plants are things like this, invasive species, such as Phragmites. So C3 means invasive species. C4 are typical salt marsh plants. So the typical things we find in a marsh are C4 plants. And then plankton are the plants that are floating in the water column. So we can use the isotopes of carbon to figure out the difference between invasive plants, salt marsh plants, and plants in the water column. Similarly, we can use nitrogen isotopes to look at what level of the food web a fish is a critter, an animal, anything is feeding at. And so here I've reconstructed a basic salt marsh food web where you've got plants, so invasive species, salt marsh plant, plankton, and then critters like worms and snails eat the plants. And then things like shrimp and that mummy chug fish I mentioned eat those, and then maybe eels are eating the top. This is just my guess. And so we know that there's a predictable step in nitrogen isotopes between each one. And so the whole point of this is by looking at the amount of nitrogen in an animal and the amount of carbon, we can figure out what plants it was eating and where in the food web it exists. And that was data that was a result of one of those first 2 experiments I ran. So what I did is I collected eels. Actually, I collected everything. I collected eels, mummy chugs, crabs, anything an eel might be eating. And I collected them above a tidal restriction. See, here's my undersized culvert. And below. And then I went to a stream that didn't have a culvert, and I collected them above and below. And I collected everything I could find because I was trying to reconstruct this food web. There's everything I could find. And there, look at so here, these are all yellow eels. I don't know, can you see that down the corner here? This big giant guy, medium, kind of little. So there's huge variability in the size in the yellow eel life stage. And I told you this was the driest part. Here, these symbols right here are all eels that I caught. And you can see I plotted them against the carbon and the nitrogen. Here are all the different food sources. So basically what you can do is look at the food sources and look at the eels, and then you put them into this magic program that basically tells you the odds that a eel is eating any one of these given things. And even just looking at this, so like what's this? All of these eels are pulled over to this direction to the right? So whatever this is probably playing some dominant role in these eels' diet, right? Because they're all skewing this way. So what is this? Salt marsh grasses. That's a little teaser as to my results. So here I put it into this like magic algorithm and it spits out all these numbers. And basically, and then I also did some gut content analysis, and we can look at these data later too if you want, if you're interested. And then, wait, do I have, well, I'm not going to tell you what I found yet, but here's that trophic position, that level of the food web. Where in the food web are these eels eating? And these abbreviations tell you what site. I looked at 3 different estuaries. And just all I want you to do is look at these numbers. Where are the numbers big? Where are they little? Pretty big, pretty big. Some variability, right? Kind of little, but pretty big, pretty small. And so what we found is that eels that were found above a tidal restriction, upstream of a tidal restriction, where there's less flow going in and out and presumably a different species assemblage of potential food, these eels were feeding at a lower level in the food web. So presumably they don't have as much good food. I mean, an eel that's eating, this eel was almost 6 lengths, six levels of food web until you got to the eel. So that's a pretty rich, robust, diverse system. So that's an indicator that this system here, this is the Parker River estuary in Massachusetts, that's pretty highly functioning, in really good shape, and eels are really happy there. Here, the Web-Handed estuary in Wells, Maine, if any of you are familiar with Drake's Island Road in Wells, and there's a culvert under there that's got a tide gate, and we're going to talk a little bit more about that tide gate in a second. Eels are not so happy. Like, they're feeding directly on one thing low on the food web. So this gives us a sense not only of how healthy the eels are, but the system itself. Yeah?
So the eels with a higher number are most likely bigger?
Potentially. I could look at that. I didn't, but I could. But yeah, presumably healthier. That's right. Yeah, that's right. I think that's a fair assumption to make. And so what I didn't step you through all these data, but I did hint at it back here. What we found were eels were relying a lot on food in the salt marsh, and they were relying on it over time. And so what that tells us is eels use salt marshes. And I know this sounds like a ton of data and a ton of work to say something probably potentially obvious, but I think that's often what science is. Collecting a lot of data to prove things we kind of already thought. But what these data suggest are eels are functioning as top predators in New England salt marshes. And I'm going to hopefully in the next section I'll talk about why that might be important. Second, eels are marsh residents. They're not just coming in there and eating a little and then taking off. We saw these signatures over time in their tissues. I was looking at their muscle tissue and their liver tissue, and then I took their slime. And slime turns over really fast, so that's an idea of what they ate within the last month or two. Muscle takes a really long time to pick up the signature of the food. So that's an indicator of what they've been eating for like over a year or so. So I had these different time stamps of what they've been eating. And so what we found is that they had been eating salt marsh food over long periods of time. So we've got eels that are staying in our marshes for a long time. And then of course that tidal restriction thing, the food web is compromised upstream of a tidal restriction. So I want to tell you a little bit about the last experiment I ran, and this one is arguably a little more fun. And this was a telemetry experiment. So I put tags in eels and got to see where they swam. And so this is the equipment I used. This is what was surgically implanted into the eels. It was, I want to say it's like 7 millimeters tall, so that's obviously not to scale. And then this is the receiver. So I put these in marsh creeks, And then next to it were these little loggers that measured temperature and light, because we wanted to see if these things affected eel movement. So here I am surgically implanting a transmitter. You can see it's right here in the eel. This is a yellow eel. This is my surgical station. So my guess, this is a little hard for me to see, and I know what I'm looking at, so I'm guessing this is pretty hard for you to see. But this is the web-handed estuary in Wells. This is, I think I said Drakeside Road before, which is in Hampton. This is Drake's Island Road. And under here is a culvert that's tidally restricted, but they opened it up and stuck a tide gate on it a few years ago. So basically, if they just restored the culvert, it would let too much water in and it would flood out some of these homes. So they put this like flap on it, so once it reaches a certain water level, it shuts and it can't let any more water in. So you can imagine how this culvert that occasionally shuts off could be an impediment to fish movement. And so wherever you see a red dot, that's where I stuck a receiver to collect data on eels. And so these little transmitters, they were about $300 each, and I dropped one in the marsh. So I was supposed to tag 10 fish, but I tagged 9. That's a bad day. So I have this array of receivers in this creek, which does not have a tidal restriction, in this creek, which has that tide gate, and then out here, so I could get a sense if they were leaving the estuary. And here are the count data, and again, this is so hard to see, but I think the one thing that hopefully stands out to you is this number right here. So we've got 18 or 48, what does that say? 18, 53, 62, 55, 14, 55, 63, 24,829. So there's an outlier here, right? And it's the one above the tide gate. So this is the number of detections. So whenever within line of sight an eel went by that receiver, it recorded that eel's number. So each one had its own tag, so we could identify the individuals. And what we found were the eels in this. So some of the eels hung out going back and forth here. Some took off and went up to freshwater. Some took off and went down to other parts of the estuary or out back onto the coastal waters. But some remained in here. And these didn't die. I made sure of that. They moved around. They moved back and forth. They occasionally even went through the tide gate. So the tide gate wasn't a total barrier to their movement. The eels could get through that tide gate, but you figure the windows of opportunity that they can move back and forth are probably decreased. So what does that mean? The fish can't get out whenever they want to. They can only get out when they have these, the right velocity of water and the gates open. And so again, it's these narrow windows. So taking the data, the isotope data I mentioned, and taking the telemetry data I mentioned, let's put that together and we'll start to craft a story of what might be happening here. So first, we know from the stable isotope data that salt marshes are important to eels. Eels live in salt marshes, they feed in salt marshes, they're an important part of the food web in salt marshes. And this is newish information. Tidal restrictions, these undersized culverts, affect the available resources for eels and they affect the food web as a whole and where eels are on that food web. We know from previous research I've done that when a tidal restriction increases the water going through a culvert, it decreases fish movement through that culvert. So again, this idea of limiting fish movement, fish access to resources, fish ability to escape a predator. And so we know that these tide gates, such as in Wells, we know that they're decreasing fish movement in these systems, which means when these fish are ready to outmigrate, when they've metamorphosed into their silver eel life stage, and when they're ready to reproduce, and they're like, all right, I got my fat reserves, I'm ready to get on out to the Sargasso Sea, and they can't, that's a problem, because we know that they outmigrate under pretty specific conditions, under specific flood stages, so certain amounts of water in the systems, typically under full moons. So if you don't have all of these aligning, we're not going to have as many eels leaving these systems to go create more eels. And so that becomes a problem because, and so this is this idea of our silver eel out migrating to the Sargasso Sea and us potentially creating barriers to that. In the Gulf of Mexico, they have this really lovely story called Trophic Relay, where critters come into their salt marshes and they feed upon things that live in the marsh, or they feed upon the marsh itself. It's mostly shrimp species. And then those shrimp species have tremendous commercial value. So in the Gulf, and we know they're losing their marshes, and it's a very challenging situation, but in the Gulf of Mexico, there's this really lovely story about the economic value of their salt marshes. And it's mostly because of this concept of trophic relay and things that eat in the marsh. We don't have as tight a story as they have in the Gulf of Mexico here in the Gulf of Maine. We've got some fish that come in occasionally, and then we've got fish that live in the marsh that aren't of tremendous value. Until now, we start to think about the eel and the economic value of the eel and the role in salt marshes as being habitat and food resources for American eels. So there's the potential now that we're starting to craft a story about the economic value of our salt marshes for American eels. Okay, and so the last one is our pitch. We must maintain the ecological integrity of salt marshes to support eels. Okay, so now, moving on. Now here's a project that you can get involved with. This is a glass eel monitoring project so all that stuff I just mentioned happened in the past. But this is an ongoing project now, and this is under my current purview with New Hampshire Sea Grant and UNH Extension. And this is a citizen science project to collect data on glass eels. So I'm not going to tell you too much about it because we have a short video about the project, and then I can fill in any gaps, or if you have questions about the project, please answer them. But you can get a break from me talking, assuming this works. Yeah, there's no video either. It's embedded too. It doesn't require the internet. Well, maybe we'll skip. Yeah. So you can't really see that. So why don't I tell you about the project? Let's go back. So we work with New Hampshire Fish and Game. Under the fishery, so eels are commercial fishery, which means there is a fishery management plan for them. So there is a body of federal and state agency staff members who collect data and analyze the data to figure out, okay, this is an acceptable number of fish for fishermen to collect to sustain the population. So that's the Atlantic State Marine Fisheries Commission that regulates that. So there is a fishery management plan for eels, and under the fishery management plan, every state that has an American eel population, which is everyone on the eastern seaboard, should be collecting data on the ingress, so the movement inland, of juvenile American eels, so that's glass eels and elvers, at least 2 sites. So New Hampshire Fish and Game is woefully underfunded, and so they were collecting data at 1 site. And they had kind of a pass from the Atlantic State Marine Fisheries Commission, citing a lack of resources to monitor at the 2 sites. So 2 sites were mandated, but they were collecting data at only 1. The lamprey, that dam I showed you before. And so when I came into this job, and having a little bit of a bias toward eels, I approached them and said, I have this group of citizen scientists. I have a feeling that they would love to collect data on eels. What do you say we set up a 2nd site, we get you to that threshold of monitoring at 2 sites, and we have a really cool experience for our volunteers. And so our eel monitoring project was born. I think we'll see in a second, we have 5 or 6 years of data. This project, we go out 5 days a week for 10 weeks. So every day, we've got at least 2 volunteers out there, and we've got a setup on the Oyster River in Durham, New Hampshire. So here's our coast, here's Great Bay. I cannot figure, where are we? We're up here somewhere? And on the Oyster River here in Durham, which is one of the tributaries of Great Bay. So in a few weeks, I was just telling Linda, we wait to hear from the folks in Maine, or excuse me, the folks in Massachusetts. When they start to see glass eels, then Fish and Game will go and set up our apparatus, and then we'll start monitoring. So every day, 2 days a week, every day for 10 weeks, every weekday, we'll be out there collecting data on glass eels. And this goes into the fishery management plan for eels. Some of the data we collect is on pigment stage. This is probably the most tedious part, wouldn't you say, of the protocol. But you will get the hang of it because I'm, of course, recruiting all of you to come down and try it. It is really fun. Unfortunately, the video gives you a good sense of what these little guys look like and what the actual procedure is like, but just indulge me and try to visualize it. Yeah, okay, so we collect, I'll have to tell you a little bit more without any images, but we collect, what these folks are doing here is we have fish boards, and have any of you ever tried to handle an American eel, pick one up, or, yeah, is it easy? No.
Very slippery.
Yeah, so slippery, and when they get stressed, they secrete mucus, and so they're even more slippery, and they're just the hardest things to hold. So we anesthetize them. Fish and Game has been an incredible partner because from the literature, we know that clove oil is the least stressful anesthetic on American eels, and that was not their original protocol, and they worked with us to create this new protocol and actually our citizen scientists did a great job kind of reporting back their experiences with different levels of clove oil, so we now use this great partnership between us and Fish and Game and our volunteers. We've figured out a protocol for using clove oil. So we anesthetize the eels, and then we collect length data on them. Then we collect that pigment data. Then we put them into a recovery bucket, and we wait until they're happy and swimming around again, and then we release them upstream of the dam. And we have learned, because have you ever been out there with the snapping turtle? There's a snapping turtle that figured out our release point, and so he would just sit there waiting for us to dump these eels into his mouth. So sometimes we have to vary where we release them. But that's generally the idea. And the cool thing about this project is we don't require a commitment. So if you ever expect to be down on the coast or down in Durham, give me a shout if you want to come check this out. You know, you can come out once and that's fine. You know, you don't have to commit to doing it a million times, but it's a really cool experience to get to interact with these fascinating creatures. I did put over there with the AWA materials, there's information about our program, the Coastal Research Volunteers, and my contact information's on the back. We have stickers too. But I do encourage you to join us. It's pretty fun and an opportunity to interact with a critter that, you know, you don't typically get to. So here's some data that, I know, more data, but just look at this column. This is our total number per year. So 2013 was our first year doing this. By the time it was a new system, a new method for catching the eels. By the time we got it set up, we got it set up May 14th, and this is the peak run each year. So we had missed the peak. So we only had 481 eels that year. The following year, and ask Linda about this. Ask her about showing up, and they travel up this little pipe and then dump into a bucket, and the bucket is locked in a box. So you open up the box and then you get to see your catch, and some days it's 10 eels, or some days it's 100, or some days it's 3,000, and it's this writhing mass of these little critters. So that was fun. But we have seen, look at this, numbers aren't as good the last 3 years, and 621 eels total over 10 weeks, over 2.5 months last year. But what's happening is we're having these late springs, right? We're having these unseasonably warm springs, and then all of a sudden in April it decides to get cold, and it stays cold for a while, and eel migration is triggered by temperature, by water temperature. So as long as the water's staying cold, the eels aren't coming. They're hunkered down in the sediment trying to stay warm. So once it starts to warm up and we see water temperatures start to increase to about 11 degrees C, then we'll start to see eels coming in. And so what's happening these last few years is, I think, we're having these later springs, and then the eels start coming, And then we're having these huge rainstorms, and we get these huge pulses of water. And so think of all of this volume of water coming very quickly down our rivers, and the eels are like, forget that, I'm this big, I am not swimming against that. And so then again, they hunker down, maybe they stay in the estuary, maybe they stay in the marsh, but we're not seeing as many. So that's my suspicion of what's happened, these 3 years versus this one. And then this shows you these black bars are the number of eels, and then this is the mean discharge of the river. And so this kind of just speaks to what I just said. So, we had a pulse of eels here with low river flow. River flow got lower and lower, still some eels coming. And then we had this huge pulse of water coming down the rivers, and the eels were like, forget it. And then there was like a little trickle of eels later on in June, but that was really it. So they're a little picky. They want the right conditions. Which year? That was 20. Let's see. This was over 1,000 eels in one day, so that must have been 2015. Yeah, that was 2015. So now I would like to spend a little bit of time talking about current events and what eels are up to lately. Eels in the news is what I have called it. So I'm going to kind of step you through year by year what's been going on, because for about the past 6 years, eels have, I think eels were really not on anyone's radar in the U.S., but things have changed. So first, to kind of set the stage for why eels have become more valuable here in the U.S., in 2010, the European Union banned the export of European eels. So I should say in Japan, there's an analogous species to our American eel called the Japanese eel. In Europe, cleverly named, there's the European eel. And in both of those, country and continent, the eels are highly valued as a food resource. And particularly in Japan, it's very tied to their culture. Unagi kabayaki is like a national dish, and they consume it in tremendous numbers, and so eels are incredibly, incredibly important to them culturally. So know that eels are highly valued in Europe and Southeast Asia. So due to a variety of reasons, just like here, eel populations have been in decline in Europe, and so then Europe placed this ban on the European eel in 2010. In 2011, recall there was that big tsunami in Southeast Asia, which destroyed many of the aquaculture facilities in Southeast Asia, including in Japan. Now, I should say, no one, adding to the mystery of the American eel, no one has figured out how to breed American eels in captivity. No one can do it. There's tremendous resources, particularly in Japan, going to scientists trying to figure this out. And on my graduate committee is a researcher named Ken Oliveira, who's down at UMass Amherst, and he's an eel biologist, and I remember calling him one day to ask him about something, and he was so excited because he had gotten a female eel to ovulate. I did it! She ovulated! So it was a funny conversation, but he hasn't gotten any further than that either. So it is this great mystery, and there is tremendous potential value. If someone can figure out how to get these things to make babies, there will be tremendous money there. But for now, all eel farms are catching eels out in the wild, catching the main glass eels and Elvers at small size, because at that size they're much easier to ship, shipping them over to Southeast Asia, where they're then held in facilities and grown to a certain size, and then sent out into the restaurant industry or the food industry. So there's everything, all eel farms, all eel aquaculture is all wild caught. It's all getting these eels from the wild. So due to declines in Europe, declines in Asia, in 2011, attention focuses on our American eels. And here's some glass eels, a handful of glass eels, I'm not going to spoil it yet, how much that handful is probably worth right now. So that shift toward the American eel, all of a sudden in 2012, there was this explosion in the Maine Elver fishery. A pound of Glass eels was valued in 2012 at $2,000. So think about the fishery too. So we've got commercial fishermen here in the Northeast that are risking their lives to go out on the water in incredibly dangerous and treacherous conditions to catch fish that they bring back and get like $6 a pound for, or something like that. To catch glass eels, you have two options. You have a dip net that if you participate in Linda's benthic macroinvertebrate monitoring project, you will use. It is literally a stick with a net on it, and you, at least to collect glass eels, you just swipe it through the water. So these people are standing in waders in a couple feet of water on the bank or in the river, just swinging it. And that's how dangerous it is. And they're netting $2,000 a pound. So you can see why there was a rush to this industry. It's much safer, it's a much bigger payoff, much more lucrative. So the main Elver fishery in 2012 is valued at, $38. That is wrong if you look at my note up there. $38 million. And it's a very short window of time too. It's just like a month and a half or 2 months of a fishery. $38 million. That's 13 times the value of the fishery 2 years prior. So as a result, there was a lot of poaching in New Hampshire. People were like, oh, okay, I could get in on this. And so at every tidal river in New Hampshire, our New Hampshire Fish and Game Conservation officers were catching poachers. And so these are just two headlines that I nabbed. This one actually from last year, I think, 2 years ago. But this one happened in that 2012-2013 rush of people trying to cash in on this industry. Because at this point, it was a pretty unregulated industry because no one cared about the eels prior to 2012. It was just kind of this smaller, not hobby industry, but it didn't have much value. I will point out, these are not American eels. If you go to the Boston Aquarium, they have that cool tank of like garden eels, I think they're called. That's what these are. Okay, so the state of Maine says, whoa, this is getting out of control. We need to get a handle on this. And so they institute a swipe card system, which is like this revolutionary system in fisheries where the people who buy the eels and then each fisherman have, like a credit card swiper. And so the fishermen get a card with their quota on it, and every time they sell their eels, then the dealer swipes it, and so there's this record of eel transactions. And this, I think does a good job of limiting poaching. Probably not eliminating it, but limiting it. Just following that, well, actually prior to that, I think the petition was filed a few years prior to 2015. A petition was filed to list the American eel on the Endangered Species Act. So that triggers a review process, a few years of review looking at the data, and the U.S. Fish and Wildlife Service determined they would not list the American eel. Any idea why? Anyone want to take a guess based on what you know about American eels? That's a good guess. That was not a factor that was cited in the determination. I would imagine there's a layer of that. The reason that was cited is because of their genetic fitness. So remember that they randomly mate. So it's not, and then they disperse to randomly, and then have the ability to live in a variety of different habitats. They can live in freshwater, they can live in saltwater, they can live in a puddle, a pond, a lake, a river, a salt marsh, an oyster reef, a seagrass bed. What's that?
Or a canal.
Or a canal. So they are adapted to live about anywhere. So the U.S. Fish and Wildlife said, they'll be fine. Like, they are going to figure it out. They can adapt to whatever conditions because their genetics allow them to do that. Wow, I went out of order here. Okay, I know why. So here's some interesting research coming out of Canada. And so I went out of order because I think I wanted this one to set up the next one. So again, I told you that eels, we have no idea really what happens once they leave the continental shelf and make their way to the Sargasso Sea or the reverse. Well, in 2012, researchers in Canada put these really expensive, much more expensive than the tags I used, put these tags on American eels. to try and figure out what was their route to the Sargasso Sea and really crack this mystery. Well, they had 7 eels that actually sent information back. These were satellite tags, so they stay on the eel and then eventually they pop off after a few months. And once they hit the surface, they send their data to a satellite and then you can retrieve it. So they only had 7 eels that actually transmitted data. 6 of them they could figure out from the temperature data were eaten by something that's warm-blooded. So they found that there was this like drastic temperature change. And so they said, okay, they've been preyed upon something that's warm-blooded. So knowing that it was warm-blooded and then looking at the depth profiles of how it swam, they figured out that poor beagle sharks had preyed upon those 6 eels. So no data on what's actually happening to eels as they make their way to the Sargasso Sea, but kind of cool information on what's eating them. Not the exact same research group, but a few of the same researchers then more recently made headlines because they tagged, I forget how many eels, but it was a lot of money of tags, and they had one single eel, eel number 28, a female, that they released in the St. Lawrence River, and then I guess we pick her up here, and she made a beeline east, zigzagged back west, and then headed due south to the Sargasso Sea. And this line here is the Sargasso Sea. And then they didn't collect any more data. They didn't get any more data from that eel after that. And this was in the eel world, at least, the eel community, which arguably is rather small. This was huge. Like, we found out what's happening. And what they found was a bit of what we suspected, is that she was going really, really deep at like, I want to say like 2,000 feet deep. She was swimming, making her way to the Sargasso Sea.
Did that just maybe when her tag popped off? Or?
Yes, yeah. So the hunch is that either it just fell off. It was if.
And, I mean, is that a big problem with illegal fishing in states where it's not allowed?
Yeah, and I remember reading that story, and that was to curb that behavior was why that swipe card system was instituted. But that happened, if I'm not mistaken, since that swipe card system. Yeah, so I'm not sure the details of how that dealer, circumvented the system, but I know poaching still is a problem. I mean, whenever I chat with the Fish and Game folks, even last year, they find those dip nets buried at every main stem river, and even our collection box says, don't tell anyone, says New Hampshire Fish and Game water quality. So they're trying to just, not attract people to the bounty that is inside that box.
$2,000 a pound, it's going to attract interest.
Yeah. Oh yeah.
If those are the babies right there,
Yeah.
and that's worth $2,000 a pound,
Yeah.
don't they send them somewhere to grow bigger and they're worth more? Is that the plan? So these are like the seeds.
Yes, exactly. Yeah, these functions of
They
this.
don't eat them at this size. They eat them more when they're bigger.
Typically. Now there are places, I can remember as I was learning more about eels culturally, and there is a dish in Spain where it's a bowl, it's glass eels cooked with like garlic and olive oil, and it looks like a bowl of spaghetti. There were quite a few shivers. But I would imagine for most people that's cost prohibitive right now. I'm sure there's some subset of people that are still eating them at this size, but I think for the most part they're being
Just let
grown.
it grow and
Yeah.
it's worth more.
Yeah.
They send them to Japan? Japan and China.
Yeah, and Korea. Yeah, so all of those countries eat them, but Japan is the one with, I think, the strongest cultural connection to it. And I will say, if any of you go eat sushi and you eat unagi.
Unagi is smoked eel.
Yeah.
Question, in the 80s I lived in Massachusetts on the Braintree Weymouth line, and there's a river there, and once a year you'd see people out there with a trident, a very specific kind of, and they'd shove them down into the mud during low tide, I think it was, or something, and they would gather them, and that was eaten, obviously, at that point. Now, would that be considered illegal, or is that just a method of fishing and,
I would imagine there's a recreational fishery for eels in Massachusetts. I mean, there is in most states, so that was probably people just out fishing, like you would, but
it's a traditional thing to do.
Yeah.
For hundreds of years. So
Yeah, and that's called an eel fork, and it's got like a tine that kind of comes back up, and then it, yeah, yep.
Right, and-
Yeah.
But the other question is, around here in the lakes and ponds that we have, are there full-size eels in there? And do they burrow in the wintertime under the mud, I guess is what you're saying?
Yes and yes.
And then they move up, swim around and do whatever they do and everything, okay.
Yeah, and
They're
typically,
slippery, you said too, which I was, or
slippery?
slimy.
Yeah, so when they get stressed, they'll secrete. So there's a slime eel, which is a different species, which is like a whole other thing. But these eels will, when they're stressed out, and think about it, if you're a predator trying to eat this thing and it's making itself harder to catch and less palatable, it's a pretty good adaptation. So they'll start to secrete this slime when they get stressed out. So, you know, they're not as slimy until they get freaked out, and then they get very slimy. But typically it's the females, and again, there's, you know, always exceptions to the rules in nature, but typically it's the females we find that make their way. So in your area, in this watershed, you would typically find females in your lakes, and the females are the ones that can get over a meter, that can get about 4 feet long. So you guys I would expect you to get the big ones.
And they will still eventually be able to work their way back to the surface.
Yeah, so this is where dams cause a problem. The little guys can get up the dams, but getting back down the dams is a challenge. I think often eels will go out over the land on a dewy night rather than maybe go take a huge plunge. They will take a big plunge, but I think alternatively they'll find the land if they need to. Hydro turbine, like hydropower dams, those turbines unfortunately cause a lot of eel casualties, so that's a problem in terms of their downstream migration. But yeah, anyway, typically it's in the headwater systems further upstream. In ponds and lakes, it's typically large females, and then it's typically, and they're the more long-lived ones. They're the ones that live 20, 30, 40 years. And then in coastal systems, we tend to find smaller males.
My final question is, do they bite?
So when I'm with kids, my own kids included, I always say any wild animal can bite, but I've never been bitten by an eel. I mean, yeah, kind of, but I mean, if it bit, I was gonna say, if it bit you, it wouldn't hurt. It wouldn't draw blood. They're harmless.
I've gotten bitten.
Oh, you have? Yeah, and it didn't break the skin or anything, right? Yeah, I wouldn't think so. Their teeth are
Very teeny.
tiny. Yeah.
And that was a big eel.
Was it? Yeah. Yeah. Yeah.
So how long can they stay on the border? If they go across on a wet night, how long can they stay out?
I mean, I don't have data on that, but I guess there are eels that have been observed traveling over a mile. And you figure, I don't know how fast they're going, but probably, I don't know, 5 miles an hour.
So they slither on top of the wet grass like snakes can.
Exactly, yeah, exactly. And an eel has a mechanism to breathe through its skin. So it would rather be out of the water than in poor quality water. So if it's in water with a low oxygen content, it will haul itself out of the water to breathe through its skin rather than live in a poor oxygen depleted aquatic environment. So they have these, you know, so part of me, you know, you can see why the U.S. Fish and Wildlife Service was like, well, they have some pretty good adaptations to living everywhere. But then again, you think of that list of threats to their population, you're like, wow, but they also have this and this and this and this and this going against them. Yeah,
Can I ask another one?
of course.
Okay, so if the females get to be about a meter long,
Yeah.
do you think, right, you should not know, do you think that they can lay more eggs than a smaller female?
Presumably. So yes, you're getting at something that researchers have found, which is that 2 different strategies. The female has a size maximizing strategy, because the idea is that the bigger you are, the more reproductively fit and more eggs you will have, and so the better success you'll have at reproducing. So the females are the ones that head up into freshwater and hunker down and try and get as big as they can before they head to the Sargasso Sea. So they have a size maximizing strategy. They want to get as big as possible. The males have a time minimizing strategy. So they want to just get off and reproduce as fast as they can. So they only get so big, and then as soon as they are at some level where they can make that trek to the Sargasso Sea, they're out. So yes, the females are very much trying to increase their reproductive fitness. Yeah. Did you have a question?
I was just curious if the pressure of the water is a factor in their laying eggs and fertilizing them, where they're down deep when they travel, and the eggs would be at the bottom somewhere. I don't know, I was just...
And that's the thinking, and then presumably as they come to the surface, they're metamorphosing into that larval stage. But again, it is a complete, like you even saw that one image, it had a giant question mark.
And why they can't fertilize unless they're there, I don't know what they're, I mean, obviously the answer hasn't been found out, but...
Yeah. Yeah.
To what extent do you think dams were a positive factor in the meeting of salt marshes, or was it more also just the natural occurrence of like your water in the spring?
Yeah, it's a good question. I mean, no one has specifically looked at that.
Were they there before the dams, or not as much probably?
Our hunch is they probably were there because looking at the Native Americans who were here before any of the dams, eels were a prized food resource. And so my hunch is that eels historically were just much more abundant than they are now. And so I think they were more in the rivers, more in the marshes. But I do think they were in the marshes because we know our coastal communities were indigenous people were valuing eels as a resource. But I will say I have had a similar thought. I mean, because you figure in dams, some of them have been around since the 17th century. So they've been here a very long time. It's not a new problem. Yeah, so I do wonder, has that then pushed more of the population to exploiting these coastal systems? Some of them never even come into the marsh and are fully marine, aren't even in the estuary. So, I mean, I've had a similar thought, but no data on that I'm aware of. At least at this point.
And at this point, it'd be hard to get data to the historical.
Yeah. Yep. Okay, so are the eels fascinating? What do you think? Did I do my job? Yeah.
I swim a lot.
Yeah.
And I know from the past, grandparents have always said there were more eels in the lake. Then they seem to have disappeared. Now, as I swim, just in the last few years, I start to see them. I have started to see them. But is there a reason that all of a sudden I'm starting to see them? And it's not like abundance, I'm just saying, okay.
Yeah, I mean, it's hard to say. I mean, it'd be lovely to say, oh, well, maybe the quotas and the management practices that are being implemented are seeing results. But remember, these are critters that are randomly distributed. They're highly mobile. I mean, their presence or absence is determined by so many factors. I mean, let's say, yes, the eel populations are rebounding, because that feels good, but it's hard to point to a driver of what that might be.
That 2012 with the 17,000 eels or whatever.
Yeah, maybe you have some 2012